we are facing the problem of expressing the case where we do not have a query string in our request. We can leave an empty string here, I guess, but that doesn't sound like a clean solution. Most languages have the concept of a no value. No represents the absence of a value. In languages with no support, variables can always be in one of two states, no or not no. The problem with no values is that if you try to use a no value as a not no value, you get an error. And this is a very easy mistake to make. Because of this reason, Rust does not support no values. But even though Rust decided to remove no from the language, it still wants to be able to express the absence of a value. It does that in a completely type-safe way, using a special enum from the standard library called Option. Here is the definition of the Option Enum in the standard library. We can see that it has two variants. It can be none, which means that there is nothing there, we have no value, or it can be some that wraps some value. This type T here is a new concept of Rust that we have not discussed yet. This means that the option is generic over some type. It can hold absolutely any type here, but this type has to explicitly be specified as part of the option type. Let's actually see that in practice. So here we said that we want our query string to be optional. So if we just wrap our string in an option like this, now our query string is the option enum wrapping the string value. So it can either be a none, this will be the case where we didn't receive any query parameters with our HTTP request, or it can be a sum that wraps a string. You can see that we use the same angle brackets syntax that is used here to define that the option is generic, and here actually we put a concrete type between the brackets. So this tells the compiler that this would be an option that is generic over a string, and it will go ahead and allocate the necessary space for the option enum holding a string. And also when we want to extract the value from the sum variant of the option, it knows that it will yield a string. So we can put any type that we want inside of an option. So we can change that to an unsigned 8-bit integer if we want, or we can even make this a method. We can put anything that we would like inside of an option and it will still work. This is the power of generics. Later in this course, we will dive much deeper in generics when we have to implement our own generic structures and generic functions. For now, let's leave this as an option of a string. Another very cool feature of the option is that because it is so widely used throughout Rust code bases, the option enum is automatically imported in every file. Otherwise, we would need to write something like use std option to pull it in scope, but the compiler does that for us. In every file that we have, it will pull the option for us. So we don't need this line here. Now we know how to express the absence of a value in a type-safe way without a fear of no pointer exceptions.